All right, so in 6.4 we're going to be talking about logarithms again, but this time we want to be discussing them graphically. So describe how the graph can be obtained from the graph of the basic logarithm, and then graph the function and state its domain and its vertical asymptote. So in our previous section, we drew some graphs to give us an idea of what our parent function looked like. So this is our parent function for the logarithmic function. We made the observation that the logarithm will always have the following 5 properties. It's going to be continuous. Its domain goes from 0 to infinity. Its range is going to go from negative infinity to infinity. Its vertical asymptote is x equals 0, and it will always contain the point 1, 0. So that gives us our basic shape that we're going to need in order to draw our logarithmic function. So we know they will always contain the point 1, 0, and they will always have a vertical asymptote at x equals to 0. So our parent function, we know, looks something like this for our logarithm. So now we need to identify the things that are happening to our logarithmic function. So the first thing we take note of is the 3 on the outside, and then we have the x minus 2 on the inside. So the x minus 2 on the inside is going to shift our graph, and minus 2 is going to shift it to the right 2 units. So that takes our point 1, 0 and moves it to the right 2 units. It will also move our vertical asymptote 2 units to the right to x equals 2. The next thing we have is 3, and that's going to stretch our graph by a factor of 3. So we're going to get pretty much the same picture, but it's just going to get stretched by a factor of 3. So we're going to get that as our function. All right, let's take a look at example number 2. So a couple of things are happening in this example that we want to take note of. We started once again with our basic parent function, which is going to have our vertical asymptote at x equals 0 and contain the point 0, 1, and it looks something like this. We want to do some comparisons, but our function is written in a non-standard form. So we need to rearrange our function a little bit. So if we change the order, we have the negative logarithm of x plus 1 plus 5. So this is just the same function, but we've now rewritten it in a slightly different order. So once again, we're going to identify our 3 things. We have a minus sign, we have an x plus 1, and we have a plus 5. So the plus 1, x plus 1 on the inside is going to shift left 1 unit. So that's going to take our point, move it left 1 unit, and it will also move our vertical asymptote 1 unit to the left. So our vertical asymptote is going to be at the point x equals -1. The next thing we need to do is we have our minus sign, And that is going to cause our graph to reflect across the x-axis. We're going to get something that looks like this. And then our last thing, the plus 5, is going to shift our graph up 5 units. So we go 1, 2, 3, 4, 5. And we'll get a graph that looks something like this. So we shifted left 1 unit, reflected across x, and then we shifted up by 5 units. So we do have a couple more questions we need to answer. So we've stated our vertical asymptote, but we want to state the domain. So we know from our notes from last time that the domain starts with 0 to infinity. In other words, it goes from the vertical asymptote to positive infinity. So when we analyze what's happening here, here our vertical asymptote in example 1 moved 2 units to the right. That happened because of this. So our domain is going to shift also 2 units to the right. So instead of starting at 0, we move it 2 units to the right to 2, and it goes up to positive infinity still. So we go from our vertical asymptote all the way to positive infinity. In our next example, example 2, we shifted 1 unit to the left. So our domain is going to be from -1 to positive infinity. All right, so same set of instructions. Describe how the graph can be obtained from the graph of the basic logarithmic function, then graph the function and state the domain and the vertical asymptote. So once again, we look on our inside and we have an x plus 2, and on our outside, we're going to have a minus 5. So the x plus 2 is going to shift left 2 units, and the minus 5 is going to shift down 5 units. So observation, moving a graph up and down will not change the vertical asymptote. So the only thing that's going to change our vertical asymptote and our domain is horizontal shifting. And so we're going to shift left 2 units. We get something that looks like this. And then we shift down 5, 1, 2, 3, 4, 5. And we get something that looks like this. So our domain, once again, is going to start at our vertical asymptote, which is -2, and go all the way out to positive infinity.